We want to start with a disclaimer that throughout this series, we feature explanations and stories that include some heavy material, including early pregnancy loss, stillbirth, and other traumatic experiences of pregnancy, childbirth, and the postpartum period. Hi, I'm Erin Welsh.
And I'm Erin Allman-Updike.
And this Podcast Will Kill You.
Today is episode 2 of our 4-part series.
4 parts.
On pregnancy.
Yep, yeah.
Yet again, coming to you from the Exactly Right Studios.
I know. I feel like I'm getting more used to it now.
Yeah?
It's good.
It's going to be like, this is the new normal?
This is the new normal. But before we get into this episode, we want to share a few words about what these 4 episodes will cover. And if you listen to our first episode, this will sound familiar to you, but in case this is your first time tuning in,
welcome.
We just want to go everything over again. Yes, welcome. But we also want to get into the language that we'll be using and our goals with creating this series. So we decided early on to dedicate 4 episodes to cover pregnancy. 1 for each trimester.
Not enough, we realized early on, but alas.
Very, very much not enough.
Yes.
And so we did realize this. And, we're not going to be able to cover everything. And throughout the series, we started to jot down like different ideas for future episodes. And so do keep in mind that, if you're listening in and you're like, ooh, I want to know more about that. Hey, send us your idea.
Yeah.
Maybe we will cover it in a future episode.
I'm sure we will.
I'm sure that we will.
So knowing that, this entire series will likely not answer all of your questions about pregnancy or cover every experience that a person can have during pregnancy. Pregnancy is an incredibly individual experience, as highlighted by all of our firsthand accounts. But what we aim to do with this whole series is take you through the broad changes that we see in the human body and that you might experience during pregnancy, childbirth, and the postpartum period, and then also explore the historical and today especially the evolutionary aspects of pregnancy and childbirth. So each episode very roughly corresponds to each trimester. So last week, we covered the first trimester, how you even know whether or not you're pregnant, and what was happening in very early development.
Yep. Then Today, in our second episode, we're going to talk about the amazing organ that is the placenta and some of the physiological changes, which are really, I'm so excited to learn more about what is happening. Okay.
I can't tell you how excited I am to talk about it.
We have 2 more episodes to briefly go through.
I know.
Yeah. But we're going to talk today about the placenta and these physiological changes that someone will experience as they go through pregnancy, including some of the complications that might arise.
Right. And then next week, in our 3rd episode, we'll talk about childbirth itself. We'll cover labor, all of the different modes of delivery, and then the history of cesarean sections.
Yep. Oh, yeah.
It's going to be good.
It's going to be good. And then finally, our 4th episode, which happens to be our season finale,
dun, 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 dun.
Will be about this concept of the 4th trimester, exploring the changes that happen after pregnancy. And we're also going to be talking big picture history about overall medicalization of pregnancy and childbirth and how the transition from home to hospital happened and some of the consequences of that.
We intend for all of these episodes to be inclusive of all families. And we recognize that not everyone who experiences pregnancy identifies as a woman. So we try wherever we can to use gender-neutral language, such as pregnant person, while at the same time, we recognize that a lot of what we're going to discuss when it comes to medical bias during pregnancy and childbirth, both historically and today, really is the result of gender discrimination as well as racism. And so in those contexts, we will also be using the term woman and women. And throughout these episodes, we'll be using terms like mother or maternal and paternal, as these are terms that are very often used in the scientific and medical literature.
And we also want to acknowledge that there is no such thing as a normal pregnancy.
Yeah.
Right? There is no textbook pregnancy.
There's plenty of textbooks about pregnancy.
Yes. But when it comes to pregnancy, there's no textbook example.
Yeah.
But we do want to also provide a baseline of the expected physiologic and anatomic changes that occurred during pregnancy, because that can help us to understand where these complications are coming from and what we actually mean by complication.
Exactly. Yeah. And so now, today, we enter the second trimester.
The second trimester, shall we?
We shall, but first,
quarantine
time.
And we're drinking again Great expectations.
Great expectations.
Yeah.
I do have great expectations for this episode.
I have great expectations for this whole series.
Me too.
Yeah.
Remind us, Erin, what is in Great Expectations?
Of course. It is blackberries muddled with mint, some ginger ale, and lemon. It's a Placeborita.
It's a Placeborita for a pregnancy series for obvious reasons.
It's great.
And if you haven't already, please do check out YouTube. Where you can find the Exactly Right Network channel that now includes our content, including a very special quarantini recipe by Georgia Hartstark. Yeah. Made just for this series. We're thrilled.
And we'll also be posting the recipes for this quarantini Placeborita set on our social media and as well as our website, thispodcastwillkillyou.com.
Have you been there yet?
Man, I get to shuttle it again to you.
On our website, thispodcastwillkillyou.com, you can find so many incredible things. For example, you can find transcripts from each and every one of our episodes. You can find a Goodreads list from where Erin Welsh likes to read books mostly.
There's also a bookshop.org affiliate account.
Yeah, I was going to say that this time. I forgot it last time. We've also got merch, some pretty incredible merch that we're repping today, if you're seeing this on video. What else do we have? We have sources from every single one of our episodes. We have links to Bloodmobile, who provides the music for all of our episodes. We've got a contact us form, a firsthand account form. Have you been to our website yet?
No one is going to want to go. They're like, I've seen it all. I've heard you talk about it all. What else? What else do I need?
Nothing new.
Nothing new.
Okay.
Shall we?
I think we shall. I don't have any other business for today.
Same.
Tell me, Erin, all about the placenta.
I really can't wait.
Good.
Let's take a break, though, and then I'll get started.
Okay.
I'm Sienna. I'm 28 years old and 28 weeks pregnant with my first child. It seems like a cliche, but my most daunting pregnancy symptom has been morning sickness. I was aware that it was a misnomer and that it would not be restricted to the morning, but my biggest surprise was how frequent, long, and intense morning sickness is. I didn't expect to lose weight during the first trimester or be woken up at 1 a.m. because of the sudden urge to vomit. I'm not a stranger to vomiting. I've thrown up before with the flu, food poisoning, intense migraines, anxiety episodes, and of course, after a night of having a little bit too much fun, as they say. But morning sickness is different. It feels similar to motion sickness, like you're on a boat all the time. When there's nothing in your stomach, the urge to throw up is so intense and you end up throwing up this thick, bright yellow fluid that looks like, honestly, like lemon Gatorade. I had my iWatch give me sound warnings from my own vomiting saying just 10 minutes at this level can cause temporary hearing loss. And in my experience, the heaving has been so intense that even if I just went to the bathroom, I still end up peeing myself. It's just so aggressive. I actually have to wear diapers now, just in the off chance that I happen to throw up. And that's just something I've accepted as part of my life now with my pregnancy journey. It has been a challenge, especially with working full time and having to commute 2.5 hours every day. You never know when morning sickness is going to strike, so I even have little bags in my car. My morning sickness started at week 5 and was pretty much all day, every day until week 22. I got a little bit of a break and then it started up again around week 26. Although it's no longer all day, it is truly just in the morning usually. And I've tried all the remedies that they tell you: ginger, B6, Unisum, pressure point bands, the list goes on. Zofran has worked the best for me, but it's still very hit or miss on whether it'll work on any given day.
Around the world and over centuries, the placenta has held and continues to hold deep meaning.
Okay.
Some cultures revere it, honoring it with a special burial. Mummified placentas have been found in ancient Egyptian tombs. You know, I would get back to ancient Egypt again.
Every
right?
one of these episodes.
Every single time. Others consume it in recognition of its power. It's been used in beauty products, preserved in a jar to ensure good health. It is varyingly seen as an older sibling, a twin, part of the baby itself, a friend, the finest jacket. This reverence is not unwarranted. The placenta, at its core, represents the fundamental, vital connection between a mother and developing fetus, a physical, metabolic, and immunologic bond. It's the first organ you make and the first you say goodbye to.
That feels so profound somehow.
Because it is.
Am I going to cry about a placenta?
No, I just teared up a little bit myself. I've read this a million times.
Yeah, but wow, Erin.
Yeah.
Okay.
It's the only organ ever connected to another individual.
Oh my God, Erin.
It filters waste, it transfers vital nutrients, and acts as an important immunological barrier between mother and fetus. It's remarkable.
I also, I have shared before how much I love the uterus.
Yeah.
And I still feel that way. Like I feel so, I have my earrings on today. I love thank you. They're a gift from you.
Congrats to myself for the good gift. Mm-hmm.
I, especially doing this research.
Yeah.
And I haven't even learned what you're going to teach me yet. But I love the placenta.
I know.
So much.
Yeah. And I think it had always been just a secondary character.
What, in your life story? Or
in my life story, in the story that I imagined,
Yeah.
And I don't even know if I had a good idea of what a placenta looks like.
Yeah.
So, Erin, would you mind?
Do you want to see?
Yeah, I would like to see.
Okay. I have one
Erin
here today.
With us here today.
A model of a placenta.
A model of a placenta,
it's
not
a real placenta.
Mm-hmm.
Thank you to UCSD Family Medicine Department for letting me borrow this. Shout out.
Yeah. I mean, that's basically it.
It is round.
It's discoid.
It's discoid. It has vessels on one side that is connected to the baby by an umbilical cord. And then on the other side, where it was connected to the uterus, it usually is more rough and bumpy. That's why this one is like that.
Yeah. I think it's bigger than I think a lot of people think. It's bigger than I thought it would be.
And some of them are hefty.
Oh, I was looking at pictures and I was just
I don't know if I should leave this
blown
here
away.
Or
that's up to you.
I'll keep it here for
Keep it there.
for the good vibes.
But yeah, it is good vibes. Yeah, we can honor the placenta here.
Yeah.
But yeah, it is a remarkable organ.
It really is.
And I really want, if nothing else, just for us to think more about the placenta, like going forward. Anyone who's listening.
Okay.
Yeah. Because the placenta deserves this recognition.
It does.
At the same time, the placenta is also at the root of some of the most common disorders of pregnancy, such as preeclampsia. It can invade into the uterine wall too deeply, not deeply enough, or in a problematic spot. It can separate too early, or not separate when it should. And the placenta acting in these unexpected ways can lead to potentially harmful or even deadly consequences for both fetus and pregnant person. As I'm always saying on this podcast, life is full of trade-offs, and the placenta is no exception. The intimacy formed by this connection is necessary for fetal growth and development, but it can also leave both mother and fetus vulnerable when things go wrong. Despite this potentially high cost, the placenta is a widespread feature of mammals, and it has evolved in many other classes of animals. The how and why of that evolutionary story is what I'm going to talk about today.
I'm so excited.
From the human placenta's ancient origins to the diversity we see in the placentas of present-day mammals, from the role viruses may have played in its development to some of the trade-offs that we humans face when it comes to our invasive placentas.
Okay.
And also what I mean by invasive.
Right.
Well, I'll get into it. My overall goal is to get us to think about why the placenta, as opposed to other reproductive strategies like egg laying, and why the human placenta, as opposed to other mammalian placentas. Like why these things? How did we get here?
Right.
Before I dig in, I want to mention a couple of things up front. The first is that I'll be talking about the placenta in terms of what it is expected to do throughout a pregnancy, which does not capture the incredible variation that can occur between individuals or even within one individual
in
throughout
like different
pregnancy.
pregnancies.
Yeah. Nor will I be exploring the multitude of things that can happen when the placenta acts outside of that. We could do an entire episode on each placental disorder. We really, really could.
Yeah.
The other thing is that this is not a comprehensive review of the placenta in all of its dimensions, like the cultural importance, the history of its study, its physiology, and so on. It's just a quick tour through one of the coolest organs. But fortunately, there are many sources where you can get that more detailed info, and we'll be posting those on our website. Okay,
give it to me.
You know that I love to start deep.
How deep are we going to go, Erin?
It's pretty deep.
Before the dinosaurs? Or
Life on Earth began in the water.
I love it when you do this, Erin. I really do.
Oh my gosh.
Okay.
And there it remained for hundreds of millions of years. We're going pretty deep.
I love it.
Around 350 to 400 million years ago, a group of four-legged animals made their way onto land.
Okay.
This group is the ancestor of all vertebrates except for fish. So it includes humans,
right,
not fish. These first land-dwelling animals couldn't quite shake their aquatic roots, and so they continued to keep laying their unfertilized eggs in water, where a male would later come by and fertilize them. This water aspect of these eggs, it's not a preference, it was a necessity. Without it, the eggs would dry out. But this reliance on water was limiting. So some of these animals evolved another strategy. Eggs covered with a more protective coating, which meant that they could last outside of water, which then enabled these animals to further explore land and go out deeper and deeper into land. But this coating made the eggs less permeable, which meant that fertilization had to happen internally, required a whole new set of things, before the egg and the yolk had fully formed. Yep.
Yeah.
And then that was in contrast to externally, like the way that frogs will lay eggs in.
Or like a lot of fish.
A lot of
spawn.
fish.
Yeah.
Right, exactly. And so then after fertilization internally and after the yolk and egg had formed, the female would then lay her eggs and wait for them to hatch, like a crocodile.
Right.
Right.
It's not the first egg-laying animal that I think of, by the way, but I love that that's the example.
What is the first one?
A bird?
Yeah, but yeah. I mean, it's true. I think of crocodiles.
I love that.
Or turtles.
I don't often think about crocodile reproduction. I think that's what it is.
But you think often about bird reproduction?
Well, I eat eggs, so.
Oh, I see.
Like egg, bird, like that's my.
Yeah, I guess I don't eat crocodile eggs, but I don't know. Also, that's so funny because when you said bird, I pictured like robins, not chickens, which is the most, oh my God.
I love it. Okay.
Yeah,
so crocodiles lay eggs.
Crocodiles lay eggs, yeah. And so, but the time window between internal fertilization and egg laying, so like when those eggs were fertilized and formed, and then when they were actually deposited, right, was variable.
Okay.
If you kept your eggs inside longer, it meant that you could more closely control the temperature and humidity that these eggs were exposed to, which could increase the chances that your offspring survived.
Okay.
Eggs can be quite vulnerable to environmental threats, like predators, weather extremes, fungal pathogens. And so some animals took this one step further, keeping the eggs inside until they were ready to hatch.
Okay.
One major transition remained, though. How did the embryo get its nutrients? How did that embryo inside the eggs?
Right.
So egg layers provided nutrients through the yolk, encased in that less permeable barrier.
Right.
But the thing is, you were limited. So like when that egg was formed, that yolk, you're just going to deplete until
that's all you have.
That's all you have.
The embryo has to be able to survive and develop enough with just whatever's in that yolk.
Yeah. It's like meal prepping, essentially.
Yeah, it's exactly like
meal prepping.
I love it.
Okay.
It really is.
Oh, okay. There you go.
Yeah.
See? But then what if you didn't want a meal prep and you're like, this is not enough food. I'm, later in the week and you're like, I'm starving.
I'm still hungry.
I don't know what I'm doing. Yeah. So what if instead you could provide nutrients to the embryo directly and continuously throughout pregnancy?
You could make your meals on the go.
Right.
Yeah.
You could always have like a resource. Oh, there's a little snack drawer.
Snack drawer.
Yeah. These metaphors might not work.
They're going a little bit off the rails, but I really like it.
We can reel it back in. And so a subset of these egg-laying animals evolved the ability to pass nutrients directly to the developing embryo, not via a yolk, but through an organ that connected mother to embryo, an organ that we know as the placenta. So we went from laying unfertilized eggs in water to laying fertilized eggs on land to retaining those fertilized eggs for longer periods of time to then getting rid of this eggshell that didn't let nutrients in or out to directly connect with the fetus and remain in contact for the duration of pregnancy.
Okay.
That's how we got
boom, boom, boom
to the placenta.
Straightforward, honestly.
Right. Okay. It's an oversimplification, of course. It's like covering hundreds of millions of years. And I also don't want to, with this explanation, give off the impression that the placenta or live birth is like the end-all be-all reproductive strategy, or that it's one unique to mammals. Like I said earlier, it evolved independently in many classes of animals, and the fact that we see so many different reproductive strategies today, like laying unfertilized eggs, laying fertilized eggs, retaining eggs until they're ready to hatch, live birth, and so on, the variation is endless.
Yeah.
What was the one that I texted you about? Gastric brooding frogs?
Yeah. And then I came back with the seahorses.
Yes.
Yeah.
I know. There are so many different ways.
So many reproductive strategies.
It's incredible. And this shows us that there are pros and cons for each, and that what works for one species might not work for another. Sure, laying eggs might make them more susceptible to external threats, but it frees you up. Outrunning or outflying a predator is more challenging when you're carrying around a load of offspring in your uterus.
Literally.
On the other hand, investment in offspring is generally higher in placental mammals, which can translate into higher survival for those offspring. I mean, we could spend hours discussing and, arguing the trade-offs of different reproductive strategies, but we're not going to do that today. No. So I mentioned that the placenta evolved independently multiple times across the animal kingdom.
Yeah, what?
In mammals, though, it happened just once. I'm only going to talk about the mammals,
Okay.
right?
And now I really want to know about the other ones, though, just so you know.
I can send you some sources, Erin.
Thank you.
Go to our website, thispodcastwithyu.com. Go to the sources tab. No. But this means that the incredible placental diversity that we see in mammals today comes from just one origin.
Wow.
Around 250 million years ago, we still have to go far back, a group of animals called the therapsids split off from the rest.
Okay.
And these were reptile-like creatures, and they differed from the rest in 3 key ways.
Okay.
First, they could generate their own body heat and maintain temperature, crucial. Second, they had body hair, which helped provide insulation for heat maintenance. And third, they developed the ability to produce milk.
Oh. Interesting.
I know. I didn't know it went that far back.
Me neither.
Yeah.
Okay.
Over the next 100 million years or so, this group continued to diversify, splitting off into the 3 main groups that today make up modern mammals. We've got the monotremes, the egg-laying mammals like the platypus and the echidna.
Love them.
We've got the marsupials, the one who use a pouch and birth teeny tiny young, like the Tasmanian devil, kangaroo, koala, etc., some of my faves. And then the eutherians, or the placental mammals, which includes all other mammals today, including humans.
Okay.
I have to throw in this well, actually, because it bothered me as I read this, and it's probably old news to people who know more about the placenta, but marsupials also possess structures resembling a placenta. They just play a slightly different role and are very different than our placentas. And so one key difference between marsupials and eutherians is when nutrient transfer takes place. So in marsupials, it mostly takes place during lactation, while in eutherians, most nutrient transfer happens during gestation.
Got it.
Right?
I think I understand.
Yeah, so
you're
it's
saying
like
that they have something that's like a placenta, but its main role is not providing nutrients.
It's not providing the nutrients.
Okay,
yeah.
That makes sense.
But it's like, but we still call the eutherian mammals the placentals.
Okay.
And I'm just like,
well, actually.
yeah, I know. I can't resist. But what I wanted to say about lactation was that in monotremes, they don't have nipples. They have like little pores.
Yes, I knew that.
And they like the little babies lap up.
They just,
I know. It's so
interesting.
It's amazing. I know.
I want to ask more about. I won't though.
You could ask me, and I'll just say I don't know.
I don't know how to form my question. Is the problem, because it's like going back to like those early when the therapsids, like Dimetrodon.
Yeah.
Was that a therapsid or was that something? See. It's only because I'm thinking of like all of the dinosaur toys that we have at home, and I always go, well, this one's not a dinosaur.
Right, which ones are therapsids and which ones are synapsids?
I don't know. Synapsid.
Or something like that.
Yeah, that's
See, and this is where my...
Anyways.
Yeah, my deep Evo bio is...
Off topic.
Off topic. We'll bring it back to the placenta.
Let's please.
Okay. So these earliest eutherian placenta-having mammals probably emerged around 110 to 125 million years ago.
Okay.
Yeah. And from there, nature did its thing. Evolution did its thing. The asteroid that caused a mass extinction event 66 million years ago did its thing. It cleared the way for the age of mammals. Check out our blastomycosis episode for more.
So much more.
And the placenta diversified. When it comes to eutherian placentas, there's a whole lot of variation, from size to shape to invasiveness. We held up the human placenta, which is like a discoid shape. They come in all different shapes. It's amazing. One book I read suggested that it is probably the most variable of all mammalian organs.
Really?
Yeah.
That's interesting.
I mean, I wonder if every organ researcher says the same thing about their organ.
They're like, my organ is actually the most...
gallbladder is the most diverse. No.
Is it though? Sure, it's not that one.
We'll do an episode on it.
Okay.
But for today, I'm only going to get into one dimension of this variation in mammalian placentas, and that is in the invasiveness of the placenta.
When I went in for my first ultrasound at 7 weeks, the doctor was able to see a gestational sac and a yolk sac, but no fetal pole. My doctor tried to assure me that it was possible I wasn't as far along as I'd thought, but I had been tracking my ovulation and I knew this wasn't a good sign. Since this was a deeply wanted pregnancy, my doctor suggested we wait a week and do another ultrasound. At 8 weeks, the ultrasound showed some growth, a fetal pole, and a heartbeat. At first, I felt so relieved, certain that progress from the week before meant that maybe things would actually be okay. But then my doctor explained that the embryo was measuring less than 6 weeks and the heartbeat was only 84. When I got home, I turned to Google and found a study that said first trimester heart rates under 90 had a, quote, dismal prognosis. The following week, when I was 9 weeks into my pregnancy, I went in for my final ultrasound, which showed an embryo measuring only 6 weeks, 1 day, and no heartbeat. My doctor was able to schedule me for a D&C the next day. My whole pregnancy, I had no indication that anything was wrong. I had strong dark lines on my home pregnancy test, and early blood tests showed my HCG doubling at an appropriate rate. I felt lucky that I was experiencing only mild nausea, but I did have all the usual pregnancy symptoms, and I had no bleeding or spotting at all, no cramping, absolutely nothing that led me to think my pregnancy wasn't progressing exactly as it should. I knew miscarriage was common, especially for women in their late 30s like me, but I always assumed that there would be some kind of outward sign. Going through a missed miscarriage led to feelings of profound betrayal. My pregnancy wasn't viable and my body had no idea. I feel as though I am no longer able to trust the signals that my body is sending.
So you can look at invasiveness in two ways. One is in the number of cell layers separating fetal and maternal bloodstreams, and the second is in how physically deeply fetal tissue invades and restructures maternal tissue.
Okay.
So one is like how many layers are in between, and the other is like how
deep do those villi go?
Exactly. Yeah. Researchers generally group the invasiveness of the placenta into 3 categories. Okay. Sometimes there's a 4th one added, depending on the number of cellular layers.
Okay.
So on the less invasive side of things, we've got like pigs, sheep, dolphin, hippo. In the medium invasive, we got dogs, sloths, elephants, aardvarks, raccoons. And on the maximally invasive,
that was like a really wide range.
Well, that's okay. Yeah.
Okay.
Yeah. In a second.
Okay.
Yeah. On the maximally invasive, as in the placental tissue is often referred to as being bathed in maternal blood.
Right.
We've got humans and other great apes, mice, rabbits, guinea pigs, 9-banded armadillos, hyenas, and others.
Okay, that's also more than I realized.
Yeah.
That are like that, considered that invasive.
Yeah. On the invasive side of things. Yeah.
Okay.
Like in terms of the cell layers. Yeah.
Yeah.
And so unless I specify otherwise, when I'm talking about invasiveness, I'm usually referring to this classification based on cell layers between fetal and maternal blood.
Okay.
Why is there such variation? Is there a benefit to one type of placenta over another?
Okay. Yes.
Well, yes.
Or like trade-off.
Trade-offs, yeah.
Yeah.
I mean, and it's a great, we don't fully know the answer.
Classic.
Yeah. And it doesn't seem to be driven solely by like how related, like different animal groups.
Yeah.
And like, oh, well, all of the, there are some broad trends.
Okay.
But for the most part, it doesn't really seem that way.
So it's like a bunch of examples of convergent evolution, essentially? Or?
Kind of.
Okay.
Like what is driving in different species, we don't fully understand, I think, the drivers for.
Interesting.
For that, yeah. But one thing that we do know is that our invasive placenta, like the human invasive placenta, is the type that probably evolved first, and then it evolved to become less invasive.
Interesting.
Interesting indeed.
Okay.
It's possible that, like, so we're talking about trade-offs. It's possible that certain molecules like iron have a slightly more difficult time getting to the fetus in mammals with less invasive placentas, but that's not entirely clear. And another hypothesis is that the more invasive the placenta, the better the signaling in all directions, like mom to fetus, fetus to mom, placenta to mom, etc. I also read that placental transfer of certain antibodies, IgG, if you're curious, which is the most abundant in our blood, has only been observed in invasive placentas, possibly demonstrating active transport of this antibody to the fetus, which could have then, like, protective roles.
Right. Because then your fetus is basically, your baby's being born with all of the antibodies that mom has had.
Yeah.
So, like, protection from all of these things, at least passively, at least for those first few months.
Right.
Okay.
Which, question mark.
Okay.
Is not fully clear. Yeah.
Okay.
So why do we have this invasive placenta? One popular but now largely discarded hypothesis is that our invasive placentas were necessary to get enough nutrients to the developing human fetal brain. For one, our big brains came after this invasiveness.
Clearly, if this was the first type of placenta.
Well, it wasn't always known that was the case.
Yeah, that makes sense.
But two, not all animals with invasive placentas have big brains. And not all animals with big brains have invasive placentas, like dolphins, which have among the least invasive type of placenta. And four, there is no evidence that transfer of nutrients is somehow greater or more efficient in more invasive placentas compared to less invasive ones. Okay.
Interesting.
All right. The idea that invasive placentas were necessary for our big brains was based on this arrogant assumption that whatever placenta we humans have must be the most advanced and the least primitive.
It's the best.
It's the best. But since that's not the case, we may have to consider instead two related questions. What are the potential downsides to an invasive placenta, and how have those of us with invasive placentas adapted to deal with those downsides?
Right.
So let's start with one of the major potential drawbacks. The fact that during pregnancy, there is an alien thing growing inside you.
Yes.
Yes, it's 50% you.
But only 50%.
But only 50%. That other 50% is not you.
Not you.
Over the past 500 million years, which is when the first natural killer cells are thought to have evolved.
Oh my God, wow. Okay.
I know.
Wow. Okay.
I know. It shows how fundamental this idea is.
And just immunology of needing to be able to find non-self.
That is the whole point of the immune system, is distinguishing self and non-self. That is pretty much the point of any, and that's an oversimplification.
Sure.
But pretty much at its core, self versus non-self.
Self versus non-self, yeah.
And so sometimes our immune system works a little better than we want it to, like when we reject a transplanted organ. Sometimes it's a little overzealous and it blurs the line between self and non-self, as in the case of autoimmune diseases. And sometimes it might need a little help. But overall, this ability is so crucial to our survival that it's a universal feature in all multicellular life on this planet and has been for quite some time.
Yeah.
And so pregnancy then should offer a pretty huge immunological challenge.
Right.
There's this non-self thing inside you.
That has to stay there for however many months, depending on what species you are.
Right.
266 days at least.
There we go.
Ours.
Yeah.
Yeah.
Yep. Yeah.
Yeah.
And so from an immunological standpoint, our bodies should flag the newly implanted blastocyst and mount a defense against it. Sometimes this is what happens. And one potential downside of our invasive placentas is that the deeper the invasion, the higher the risk for triggering an immune response from the mother.
Right.
Many species that have similarly invasive placentas like ours tend to have much shorter gestations, in part potentially to minimize this risk. But we seem to manage overall.
Right. This is why we see things like rhesus disease, right? Where you have at least some fetal cells that are able to cross over this barrier and come onto the other side of our cells. And then we do see those and mount a defense against them in a future pregnancy, potentially.
With potentially really
disastrous consequences.
Exactly.
Yeah.
Yeah. And so there is this immune relationship that is really complex.
It's a very tight rope that we are walking.
Yep.
Yeah.
So what allows for tolerance over rejection?
Yeah.
One thing that helps is that a fetus is not the same as an organ transplant. A transplanted organ is connected to the recipient's blood supply, whereas during pregnancy, the fetal and maternal blood are kept separate.
Right.
And they are kept separate by the outer layer of the placenta. And this outer layer consists of a bunch of cells that are fused together to make a tissue. So it's not like individual cells anymore. The membranes have been fused together to create like one giant cell with like multinucleated cell.
That's why they call it a syncytial trophoblast. If you remember our RSV episode, that stands for respiratory syncytial virus. I'm going too nerdy. I'm so sorry. But syncytium, yeah, multinucleated cell.
Multinucleated cell. So it's this like one cell, but it's a long giant cell.
It goes the whole entire outside of that blastocyst.
Yep. And this tissue is pretty impenetrable because these cells are fused together. There are no more membranes between the cells, which means there aren't any gaps to let in, let's say, for example, mom's antibodies, which might flag the fetus as non-self. So it just creates this, like, there are no gaps.
Right.
You can't even
get
no foot in the door.
No maternal stuff can get in to the placenta at that point.
Yep. And this is a pretty crucial tissue, and its role is not limited to barrier, right? It's also a hugely important regulator in the expression of hormones, like upregulate that hormone, downregulate that hormone, proteins, and other molecules that are used in communication between placenta and mom. And we owe it all to an ancient virus.
Stop it.
Oh, yeah.
What?
Oh, yeah. At some point, one of our ancestors was infected with a retrovirus, which inserted its genetic material into one of their sperm or egg cells.
Okay. What?
When those cells replicated, like when they formed an embryo and so on, so did the viral DNA, carried it with it.
Okay.
Right? Which was then also passed down to subsequent generations because it would have been in all of the germ cells down the line. Over time, we lost bits of that viral DNA, but some crucial parts remained. Genes that maybe we were like, this seems like it could be worth keeping around. We call these viral remnants in general endogenous retroviruses, and our genome is chock full of them.
Okay.
I think I've talked about this before on the podcast.
I'm getting really excited.
About 5 to 8% of the human genome is of viral origin.
Erin.
5 to 8%. That's a huge proportion of us. That's not us. It's a virus. It is us. The genes syncytin-1 and syncytin-2, which help us to fuse these cells together to make that like one layer and also help us escape detection from mom, they come from a couple of these ancient viruses. That's what allows for that formation of that tissue.
What?
That barrier. Yeah.
Really?
These
genes, these viral genes, essentially. These genes that are viral in origin.
Yeah.
Wow.
Syncytin-1, syncytin-2. Without these ancient viral infections, we would not be able to form the super important tissue. We wouldn't be here.
Wow.
Yeah. Chills. And what's amazing about these endogenous retroviruses, these syncytin genes, is that they appear across eutherian mammals, but not from just one infection event. Mammals have been infected over and over again with different viruses that have found their way into our genomes and have been co-opted into helping us build this tissue layer.
Wow.
I know.
I'm being mind blown right now.
Same. I'm being mind blown, and I wrote this.
I wrote this, and it's still blowing my mind.
But the immunological relationship between mother and fetus isn't just one of avoiding detection or building barriers, right? The activation of the maternal immune system is actually a necessary part of pregnancy. And instead of that activation leading to a destructive response, it leads to a regulatory or protective one, one in which acceptance of the embryo is initiated. The portrayal of pregnancy as immunosuppressive isn't accurate.
Right.
In fact, the mother is very aware, or the mother's immune system is very aware of this new non-self thing growing. And it's more that the maternal immunological self is modified, a change in immune tolerance. As a side note, this shift in self might help to explain why some people with autoimmune diseases experience symptoms lessening during pregnancy.
Yeah.
But there may be a cost to this tolerance.
Okay.
Recent research has investigated whether our invasive placentas, which require more immune tolerance than less invasive ones, may have made us more vulnerable to cancer as a species.
Really?
Really.
I did not know this connection.
Yeah.
Okay.
It's been like, I think in the past 10-ish years or so, there's been a lot more interest in this aspect of the immunological side of placentas.
Interesting.
And placentation, yeah.
Okay.
In fact, many researchers have noted the similarities between cancer and placentation, the formation of the placenta.
Very interesting.
There is immune evasion, proliferation, invasion into other tissue, and blood vessel remodeling.
Wow.
Yeah. I know.
And it's like self, but not.
Yes.
Because it's abnormal cell division. Ooh, interesting.
Yep. And studies that have compared cancer rates across mammals have found that cancer tends to be higher in species that have more invasive placentas, like humans, compared to ones that don't, like cows.
Interesting.
And I'm sure like that other things play a role, lifespan, body size. It's never one thing.
Yeah.
Yeah. But the pattern isn't cut and dry, nor is it clear how cancer and invasive placentation might be related like mechanistically.
Right.
It's a fascinating area for future study, though, especially what it might be able to tell us about our individual responses to invasive placentation.
Yeah.
Because, wow, there is a range of responses. So like we've talked about, the placenta is more than just a gateway for communication between mother and fetus. It's also the place where we see maternal, fetal, and paternal needs expressed. From the fetus's perspective, more is better. More resources, more nutrients, more everything to help you grow.
Sometimes, and we'll get there. Not always.
Not always. But also from mom's point of view, you also want fetus to grow, but you can't give away all of your resources since that would impact your ability to care for the fetus later in pregnancy, after birth, in future pregnancies, and also for existing offspring, right? And so these needs might be in immediate conflict, but there seems to me to be an ultimate shared goal for the two, right? A healthy newborn while also not draining mom to the point where postpartum care is impossible.
Right. A little balance.
Little balance. It's like, I think a lot of people refer to it as maternal fetal conflict, which is a whole separate thing. And there are a lot of dimensions to that. And there's like also the sociology and political side and legal side of that.
Yeah.
But I have been thinking of it as like a maternal fetal conversation.
Right.
Yeah.
It's a
balance.
A balance.
It's a dance, a balance.
Yeah.
And that balance is not always struck. Sometimes, for instance, the placenta invades too deeply into the uterine wall, past the decidua, which can cause hemorrhage or perforation of the uterus. Or sometimes it doesn't invade deeply enough. And maybe this is because our immune system prevents it. This incomplete invasion is thought to be at the root of preeclampsia.
Right.
We don't know the precise mechanism or if preeclampsia has one root cause or multiple. Is it a syndrome?
Right.
Or is it one? Yeah.
I'll talk more about like the different types of preeclampsia, whether it's early term, whether it's postpartum preeclampsia. Yeah. Are they different? Are they the same?
Right.
We don't know.
Is it the same pathway that's getting us to these things or multiple pathways?
Exactly.
Yeah. But one idea for preeclampsia is that the placenta doesn't invade deeply enough, which can limit the blood supply to the placenta and fetus. Initially, earlier in pregnancy, that's not a problem since the fetus actually needs a low oxygen environment to develop. But as pregnancy progresses, oxygen demands increase. And if that initial invasion wasn't deep enough, if those arteries weren't remodeled enough, that can mean that the fetus is getting low or intermittently low oxygen. And so then mom senses this, or through the placenta is told this, and then her blood pressure will spike to compensate. But that doesn't always solve the problem. And so then things can kind of get increasingly out of balance, and then there can be a lot of danger that happens.
Yeah.
Erin, I know that you'll get into more of the details later on. But one of the things that I find fascinating about preeclampsia relates back to this idea that invasive placentas might be related to higher rates of cancer. If preeclampsia has an immunological component, and if mother's immune system is preventing deep invasion of the placenta, might cancer rates be lower in people who have had preeclampsia? I don't like. So first of all, now I'm like,
we're wondering. We are wondering this.
Yeah, I'm not saying like, and here's, there's been reviews about this and meta-analyses. I did look up a few large studies and a meta-analysis that did suggest that people who have had preeclampsia are overall less likely to develop breast cancer.
Interesting.
But there's so much more to that story. There are so many factors. How protective might preeclampsia be? What's the mechanism of protection if there is one? Is this a causal connection or just, a correlation?
Yeah.
And the same can be said for the placenta. Like there's so much more to the story. This was really just a brief, or at least as brief as I could make it.
Could keep going. I would keep listening to you.
Just a brief tour through the evolutionary history of one of the most fascinating mammalian organs out there. And I hope that even if you don't remember any one thing from this story, you at least find yourself thinking more about the placenta.
The placenta that we all used to have.
Yeah, we all used to have.
I think that's the thing that's interesting that no one ever thinks about. Like we all... Because I think a lot about the uterus and how we all came from a uterus, whether you have one or not.
Right.
You came from one, which is so interesting. But then I never thought about the fact that we all had a placenta.
We all had a placenta.
And we all no longer do.
Yeah. Unless you kept yours.
Yeah, but then that's not yours. That was your fetus's. That was your baby's placenta, technically.
But if your parent kept your
that's
placenta.
Interesting. I never thought about that. Yeah. Okay.
Yeah.
So some people might have theirs.
But I mean, it's no longer attached to us.
Yeah.
It's no longer
it doesn't serve a function
serving
anymore.
the function that
and right after birth, it stops serving its function. I mean, it's just so interesting.
And it's huge.
Yeah.
It's that takes a lot of resources.
Oh my gosh, yes.
Yeah.
It's hefty.
It's a hefty organ.
And you can tell when they're not hefty.
Oh, interesting.
Yeah, I mean, you see a whole variety of placentas when you've been delivering babies, which I haven't done a lot of, but seen a fair number, and they range for sure.
Which is amazing in and of itself.
Interesting.
I know. Okay, we could keep talking.
I'm going to
about
stop. Yeah,
I'll
close my mouth.
But that basically is the placenta story.
I love it.
Let's think about viruses. Let's think about what the placenta allows us to do from
what a journey we went on.
Immunological standpoint. It's incredible.
Yeah.
So let's keep going with the journey, Erin. Tell me what's going on with your body in pregnancy.
Okay. I literally can't wait to.
Okay, good.
We'll take a quick break and then we'll get into it.
Hi, my name is Tracy, and I was 30 years old and went off the birth control pill. I had been on it since I was 16. Hoping for the best, my husband and I went for it. 3 months into being off the pill, I was late having my period. It was a Friday night, and I would normally be having a nice gin and tonic to greet the weekend. So I went to the store and bought a pregnancy test and immediately took it. It was negative. Okay, I guess I will be having a G&T, and went into the kitchen to mix up my favorite cocktail. 5 days later, on April 1st, I had a regular checkup at my OB. She and I talked about what my plan was and that I was officially off the pill. I did the normal things at the appointment, urine sample, etc. She was gone for a bit, and when she came back into the room, she said, "Well, this is no April Fool's joke, but you're pregnant." Whoa, okay. I went home to tell my husband and thought I'd have a little fun with the fact that it was April Fool's Day. So aside from being totally shocked, we were excited and a bit terrified. The next week, I went into the doctor's office to have my HCG levels measured. My doctor said they weren't great, but perhaps that is why I got a negative reading when I had taken the test. I would need to come back into the office a few days later to see if they had increased, but they had not increased. They should be doubling at this point. I figured this pregnancy might not make it, but the good news was as I had become pregnant and I could try again. A few days later, I went back in. Nope, not having any luck with the numbers. I went back several times over a couple of weeks, and it just didn't seem like this was going to happen. Then a couple of weeks into the process, I went in for yet another test, and my doctor came into the exam room and said, "Your numbers are all great. Everything had rebounded, and I was exactly where I should be." So I thought I could get a little excited now. From then on out, aside from feeling very dizzy and sick for 4 months, she came bounding out a week early, a healthy baby girl, and now she is about to start her 3rd year of medical school. You never really know how things are going to play out. And yes, she is the one who got me hooked on TPWKY.
So I left off the biology last week, kind of at the start of the 2nd trimester. But in that episode, I mostly was talking about the embryo and the invasion and the thing and etc. But in this episode, I'm going to focus on the pregnancy and the pregnant person and not the fetus.
Okay.
Because as incredible and awesome as the process of fetal development is, like, it only happens inside of a uterus. And so, like, the changes that are required in our bodies in order for a pregnancy to actually continue to term, like, that's where the money is for me right now.
Got it. Okay.
Someday we'll do fetal development because it's really cool too.
Yeah.
Okay. So we are going to actually take steps backwards to the beginning of the pregnancy.
Okay.
Kind of.
Yeah, that makes
We're going to go
sense.
back to fertilization.
Sure.
Okay? Yeah. So that we will recall from last week is about 2 weeks after your last menstrual cycle, right, is when you ovulate and then you get fertilized. Mm-hmm. Okay. And then about 6 days after that is when we have implantation that starts. So we're about day 21-ish of our menstrual cycle.
Okay.
By about this time, and then like the next week after, when you may have missed a period and may have had that positive pregnancy test, already your own physiology has changed dramatically because of the way that embryo has embedded itself into the wall of your uterus, like you just walked us through, and started secreting hormones that are going to cause our body to change in ways that it really only changes in the context of pregnancy. I get really excited. And what I'm going to do for this episode is go through these changes, not week by week, like you might see on all of the like websites, like your body is doing this week.
Right.
No. We're going to go body system by body system.
Great.
And explain why we see maybe some of the like weird or uncomfortable symptoms that you might experience.
Okay.
And why we are susceptible to some of the complications that then arise.
Yeah.
Because of these changes in our physiology. Okay.
Uh-huh.
I'm going to rapid fire through it, but stop me at any time.
Okay.
Okay. We're going to start with our cardiovascular system because it's one of the most important and one of my favorites. One of the first changes that we see is in our blood vessels. So because of the increased levels of progesterone and other hormones like estrogen and prostaglandins, we see a dilation or a widening of our blood vessels. And what this does is decrease the resistance to flow of fluid because of physics.
Yeah.
So right away, you can start to see weird symptoms because this vasodilation can cause edema or swelling as these blood vessels, as they get wider, become a little bit more leaky. So then you get fluid that can go out through the blood vessels and into places like our ankles.
And this is like body,
anywhere.
Your whole body.
It could have, not like extreme, but a little bit.
Right. No,
a little
but
puffy.
I mean like the blood vessel widening
Yes,
is everywhere.
Everywhere in your whole body, which also means you might get things like nasal congestion or nosebleeds. Mm-hmm.
Oh my gosh.
Now, this vasodilation will also cause a decrease in your blood pressure, usually early in pregnancy, which is very interesting to then contrast with what we'll see in preeclampsia, which is when we have higher blood pressures. Now, on top of this change of the width of our blood vessels, we also have an increase in our blood volume. By how much, you might ask?
I would ask.
By 40 to 50%.
What?
Uh-huh.
Okay, tell me more about what that means.
It means that if you have, I actually meant to look up like what your normal blood volume is, however many liters, I don't remember.
Yeah.
But it is now 50% higher within a number of weeks.
Okay.
You will literally just make more blood volume. It means your plasma volume. Okay, we're going to get even more into it. Because it's your plasma volume that's primarily increasing.
Okay.
And this means a few things. Number one, it means your heart has to be able to keep up with this increased amount of flow. And so to do that, we actually see structural changes to your heart to allow for an increase in cardiac output.
What kind of structural changes?
We see thickening of the walls of the left ventricle. Oh, do you bring over the heart? Oh my gosh. If you have a diagram of a heart, your left ventricle is over here, right? And that's the aorta is going to come out here. And this is where your blood goes to the rest of your body from. Yeah. So the left ventricle of your heart is going to get a little bit thicker. Your overall heart is going to get a little bit bigger. And then as we'll talk about later, because of the changes in your diaphragm and the size of your thoracic cavity, it also gets shifted up and to the left.
Interesting.
I know. Now, also,
thank you.
Give that back to you. Now, also, we will see a compensatory increase as well in our heart rate because your overall cardiac output is a function of both the volume and also the rate. So we see an increase in heart rate, which I remember seeing on my smartwatch where it was like, you have a new normal. I'm like,
oh, interesting.
Yes.
And you're like,
when I was pregnant.
How soon does that happen?
So that is a lot of these changes are kind of gradual.
Okay.
Where they start really early, but then it just like continues to change all the way till the third trimester until term.
Okay.
For the most part.
Okay. And it's sort of it's just sort of this, it's a linear, well, not linear.
Yeah, not linear,
but I mean,
but yes, it's a kind of continual.
Unidirectional.
For the most part.
Okay.
Yeah, there's probably nuance there that I'm skipping. Now, I said your blood volume increases by 50%. However, your red blood cell volume, and remember, red blood cells are the ones that actually carry oxygen to our tissues, so they're like kind of pretty important. They also increase, but only by about 20 to 30%.
What does this then difference in rate increase? How does that manifest in other parts? Like, what is that? What are the implications of that?
Okay, let me tell you.
Why aren't your red blood cells also increasing?
They are increasing, just not
to the same degree.
Not to the same degree. So what is this? What does it mean? What are the implications?
Yeah.
It means that you have, during pregnancy, a physiologic anemia. And your blood has less viscosity. So it can
less
flow.
Viscosity.
Right, because you have less particle.
Probably a good thing, yeah.
Yeah, it can flow a little bit more easily.
Okay.
It also, though, means that, of course, you can carry a little bit less oxygen, relatively speaking. Like, on the whole, you're carrying more because everything is increased.
Yeah.
But you have this physiologic anemia. You also then have this fetus that is going to be relying on the oxygen that you are giving to them. So that means that you have to become very efficient with your oxygen transport. Which is a thing I could go really too deep on, but I won't. But what we then see during pregnancy is an increase in this production of this compound on our red blood cells called 2,3-DPG. It basically means that when you are pregnant, your body is better at giving away that oxygen.
Right.
So your red blood cells are more efficient at offloading oxygen so that the fetus can get access to that oxygen.
Okay. It's just like easier to drop off.
Exactly.
Okay.
Exactly. Yeah. It's
Amazing.
So interesting. There's also like fetal hemoglobin things that are interesting too.
Fetal hemoglobin.
I know.
It's
cool. But it also means, you said another implication. Another implication is that in order for our bodies to keep up with this demand, iron requirements are significantly higher in pregnancy compared to outside of pregnancy. And that's for two reasons. One, to support the growth of the fetus, who needs iron to grow, but also to keep up with this increased red blood cell production. And so iron deficiency anemia can develop on top of this physiologic anemia. And so during pregnancy, people are at pretty high risk of like anemia in general because you already have this physiologic anemia and now you have this increased iron requirement. So if you're not getting enough iron in your diet, then you're not able to make enough red blood cells. Does that make sense?
And so, right. And so then what if anemia, or if this 1-2 punch happens, then what are some of the downstream effects?
I mean, it can affect, it can be really problematic when we get then into delivery. Because in delivery, you are going to lose some degree of blood, most likely. And so that can put people at higher risk of complications from hemorrhage or just from blood loss in general.
Okay.
I mean, it can cause problems for the fetus as well, too, if you were like severely deficient.
And so I'm sure there's a range of physiologic anemia, like outside of iron deficient anemia.
Right.
And so is there a point at which just like physiologic anemia is where it needs
problematic?
Yeah, exactly.
I don't think so.
Okay.
Yeah. Because it is what is expected during pregnancy.
Right. Okay.
You expect that to happen. Okay, but so if we move on from our blood vessels in our cardiovascular system, we'll move to another vessel that's being affected, kind of. It's not really a vessel. It's your kidneys. They're connected by tubes.
Okay.
It's like a vessel. You have all this extra blood, right?
Yeah.
Your kidneys are responsible for filtering all of your blood. That's what they do. And so your kidneys have to work a heck of a lot harder. And during pregnancy, your kidneys enlarge and increase their filtration rate by 50%, which is so impressive and means that you're making a crap ton of urine and you have to pee all the time, even before there is a fetus literally crushing your bladder.
That's something I had never thought about.
And that's why even early in pregnancy, people be like, I'm peeing all the time. And it's not because of the fetus, because that thing is like a couple cells big. It's because you're making so much more blood. And so your kidneys are filtering all that blood. And so you're peeing all the time.
Okay.
And then eventually, of course, this fetus is going to grow large enough to crush your bladder. And when they do, you also can get compression of some of the tubes that lead from your kidneys to your bladder. And then that, along with the fact that progesterone, which I talked about already, that causes that vasodilation, progesterone also causes like a slowdown of everything. Everything's just like moving more slowly. And so your bladder has a little bit more stasis. It's not like squeezing out as much. So you can be more prone to UTIs or urinary tract infections during pregnancy.
Interesting.
Because even though you're making so much pee and you're peeing all the time, it also just can kind of sit there a little bit longer. And then because of all of these things that are happening with like compression and blah, 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 you have a higher risk of those UTIs getting up into your kidneys and causing a kidney infection.
Okay. And is that risk consistent throughout pregnancy?
I don't have an answer to that question.
Okay.
It's a good question. And it's not like it's major. Like, that's not like, oh my God. It's just like you're a little bit higher risk.
These are some of the things that happen.
Some of the things that can happen. So that was a lot. So I'm going to take a big breath.
Okay.
Just kidding. You can't take a deep breath during pregnancy.
Good one. Did you have that written out?
I did. It was a joke I wrote.
I love when your jokes are written out.
Thank you.
Still felt natural.
Thank you. It was my segue into the respiratory system.
It was a good segue.
Thank you. So the changes that happen in your respiratory system, they actually start really early in pregnancy. I think we think about the changes later in pregnancy when you have just a large volume that's compressing things, and we'll get there. But the hormonal changes actually cause an increase in ventilation called hyperventilation of pregnancy. And that starts really early. So your respiratory rate actually increases hormonally.
Okay. Hormonally. What hormones?
Progesterone mostly.
Progesterone. How does that work?
We're not going to go deep into mechanism here, Erin, because I got too many other body systems to talk about.
What makes you breathe more?
I don't know.
Okay.
I don't have any answer to that in what I wrote so far, but I got plenty of papers that you can read about. Because it does,
I'm just, amazing.
It's so cool. And then, as I have alluded to many times now, as pregnancy progresses and this uterus increases in size significantly, it displaces every single other organ in your abdomen. It moves from being a pelvic organ to an abdominal organ. And in doing so, it elevates your diaphragm, which is that muscle between your chest and your belly. And your diaphragm is what allows for your lungs to expand. It has to move down for you to take a deep breath in.
Right.
During pregnancy, this gets shoved about 4 centimeters upward. So your lungs cannot expand as fully as they could previously.
Right.
That's what also causes that displacement of the heart, which gets pushed up and a little bit to the left.
Okay.
And now some of this is compensated for, this displacement is compensated for by the same hormones like progesterone and also other ones like relaxin and things that cause ligamentous laxity.
There's a hormone called relaxin?
Relaxin.
Stop.
Just relaxin.
I want to know who named that.
I have no idea. That's
Amazing.
a you question.
Relaxin.
Yeah. So it's what allows all of your ligaments to like expand and relax so that you can like fit a baby through your pelvis. And then also so that the bottom part of your rib cage can flail out and actually expand in diameter this way, like front to back, about 5 to 7 centimeters. You get change here.
Wow.
Just the bottom part of your ribs.
All thanks to relaxin.
Relaxin, progesterone, all of these hormones. Yeah.
Not to just throw a spotlight on relaxin.
Spotlight it, give it some cred. But with all of these changes combined, by the end of pregnancy, your total lung capacity decreases by about 5%, which isn't huge.
Right.
However, because of increased demand, both because the fetus has increased demand, right? You have to share it with the fetus. And because your own basal metabolic rate during pregnancy increases by about 15%, your total oxygen consumption and need goes up by 20 to 30%.
Okay.
So
you've got, first of all, you're breathing more because progesterone is telling you to breathe more.
Yep.
Presumably,
That's how it goes.
We're not going to dig deeper into that. You've got less room for your lungs to expand, and you need to breathe more.
You need more oxygen,
and so you're like just like panting.
You feel a little bit short of breath.
Short of breath.
Yes.
Okay.
Yeah. You're not panting, but you feel short of breath.
Okay, and then also the metabolic rate.
Yeah.
Okay. Okay. There's a lot of things.
So there's
happening.
a lot of reasons to feel a little bit short of breath, especially towards the end of pregnancy.
Yeah.
Now, you also have, because of everything going on in your abdomen, right? you also have just a lot of pressure inside of your abdomen. And what this can do, especially if somebody ends up lying down flat on their back, is it can put pressure on the blood vessel that sends blood back to your heart, called the inferior vena cava. And that, because it's a vein, it has floppy walls, so it can actually become compressed later in pregnancy by the weight of the fetus and the uterus and everything else in there. And that can potentially be problematic, mostly for the fetus, because it can kind of reduce the blood flow back to the heart, thus reducing your cardiac output. And then you can have this drop in blood pressure that affects the perfusion to the fetus.
Okay.
So that's why a lot of times late in pregnancy, people are told, like, don't lay flat on your back.
Yeah.
That's the reason why.
Okay.
Yeah. We have so many more body systems. Okay, ready? Blood in general, going back a little bit, I guess. Blood clotting factors completely change during pregnancy. Nearly all of our clotting factors increase, except for our platelet count. And we think this is helpful in terms of preventing postpartum hemorrhage.
Oh.
But it also means that people are at higher risk of a thrombotic event, of a blood clot forming when it shouldn't.
But I thought that our blood was less viscous.
Oh my gosh, it is. But our clotting factors are higher.
Okay, so we're just sort of compensating for that
all
decrease in
ways.
viscosity. And then it's like the clotting factors, I mean, really, we're getting to the same end result.
Yeah.
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 More clots potential.
Potential for more clots.
Okay.
And the mechanism there, don't ask me exactly. It's probably related to estrogen, because same reason if you're on estrogen birth control, you're at higher risk, but not as high risk as when you're pregnant.
How have we not talked about that? Okay.
We did, I thought, during our birth control episode.
Oh, yeah, we did.
Yeah, we did. Okay, but all of this I've talked about so far, which was a lot, and I've already skipped over what is a lot of people's first indication symptom-wise that they might be pregnant, and that is the changes to our GI tract.
Yeah.
So from the very beginning of pregnancy, hormones, again like progesterone and others, are causing smooth muscle relaxation. That's how we get dilation of our blood vessels.
Okay.
That's why we get the stasis in our bladder, all these things. And this results in a decrease in tone of our esophageal sphincter, which goes from our esophagus into our stomach. And that can mean that you get an increase of things like acid reflux. And we think that it's also related to nausea, right? You have just like slowdown of your GI tract and opening of your esophagus and going in. So it just makes you feel more nauseous.
Why does the slowdown happen?
Because of progesterone.
Yeah, but...
Why?
Yeah.
Is it just a consequence of the fact that like progesterone is causing this overall relaxation? Probably. Like, does it have a purpose? I don't know.
Okay. And then why does that lead to nausea? Like, what is nausea?
Oh my God. Sorry. I can't believe the questions you're asking me right now.
I know, I'm sorry.
It's like, what is itch? Oh my gosh.
I still want to know what itch is. I know what nausea is.
Right. You know what it feels like.
Right.
But like, why does you can think about it too as like your food is not able to move through as quickly, so it's going to be sitting there for longer. You have things that are supposed to be staying in your stomach coming up into your esophagus more readily.
Okay.
Like, I don't know a better answer than that, and there's probably a better answer out there. Like a GI doc is like, rolling their eyes at me right now. Sorry.
No, I'm sorry.
No, don't be sorry. But yes, so this happens. And what's interesting is that mild nausea and vomiting early in pregnancy is actually associated with a lower risk of miscarriage or early pregnancy loss in the first trimester.
Yes, I have heard that.
Yes. And so we think that that is a big part of the reason that we think it's very progesterone mediated, right? Is that when you have adequate levels of progesterone, then your pregnancy is able to continue. And so if you have lesser, then you might have less nausea, but then it also might mean, you know what I'm saying?
Yeah, I do know what you're saying.
But it's not cut and dry.
Right,
it's just like a slight association.
Okay.
But as you can also hear in several of our firsthand accounts, sometimes this nausea and vomiting can become very severe, and that's called hyperemesis gravidarum. We do not fully understand the cause of hyperemesis. We think that it's probably in part these changes to the gastrointestinal tract and the mobility of our gastrointestinal tract, but also like some contribution of, is it maybe other hormones, like independent of their effect on the GI tract? There's probably some degree of genetic susceptibility. We don't know, in short.
Okay.
Yeah. We don't fully understand that one at all.
Yeah.
But this slowdown of the GI tract can also, especially later in pregnancy, end up affecting the liver and the gallbladder. And that is what can result in intrahepatic cholestasis of pregnancy or cholestasis.
Yes, I want to know more about this. I had only heard, yeah.
So it's more rare than some of the other complications, like maybe anemia or something like that. It's estimated at like 0.2 to 2% of pregnancies, depending on which studies you're looking at. But cholestasis is when we see a buildup of bile acids, because bile acids are supposed to be, they're made in the liver, and then they have to be transported through a duct into the gallbladder where they're stored. And then from the gallbladder, they have to be squeezed out and then squirted into our small intestine.
Okay.
And so we see a buildup of these bile acid because they're not being squirted out and excreted by the gallbladder.
They're stuck in the gallbladder. Gallbladder is the source of so much issue.
Right. And so they're also then they're building up in general. So it's like the liver, the gallbladder, the whole situation. They're not going down the tract like they're supposed to.
The salts are stuck in the liver, stuck in the gall. It's just sort of like the slowdown.
It's a slowdown. Yep.
Traffic jam in the gallbladder.
A traffic jam. And so then this bile acid accumulation will then be essentially like transported out of just the liver gallbladder situation and can potentially end up in our bloodstream. So then we see an increase in bile salts in our bloodstream. The symptoms of that end up being really, really severe itching. And it's usually like whole body itching. Don't ask me why it causes itching.
What is itch? No, but how does it get in the bloodstream?
Because it's not able to be transported out. So then there's just too much of it. And it's just like, pew, pew, pew. Okay. Because your liver has so much blood supply. And so if it's just backed up into your liver, then it's going to
go back.
Get kicked out. Okay. Yeah. That does not pose a problem to the pregnant person. But those bile salts can pass through the placenta and be toxic to the fetus, because these are cytotoxic compounds.
Right.
That's why they're usually stored in our gallbladder, where they're not causing problems, usually.
My name is Sarah, she, her, 36-year-old female, mother to an awesome daughter. I had a positive home pregnancy test on Christmas Day 2022. I was 34 years old at the time. We were very lucky to conceive on our very first try. We had our confirmation ultrasound at 8 weeks, and as I progressed towards the second trimester, I felt my mental health spiraling. In addition to all of the other common pregnancy side effects like morning sickness and fatigue, my anxiety started to worsen to the point of panic attacks. My body was changing in a million ways, and I had no control over any of it, let alone any peace of mind to assure me the baby was okay or how to judge what was normal. I started to feel like maybe my medical background was not an advantage in this situation because I knew too much. When I brought my fears up to my OB, I felt dismissed. Each visit was short, about 5 minutes. They checked the fetal heartbeat and sent me on my way, even though this was my first pregnancy. I took it upon myself to research pregnancy mental health and found mostly postpartum articles. I eventually talked to my PCP, who started me on Lexapro and Buspar. I was referred to a mental health provider, and over the remaining 6 months of my pregnancy, I had weekly video calls with an LCSW. She helped me develop coping strategies for my anxiety and guided me in conversations with my OB and my husband. I made affirmation journals, mantras to recite, and fell asleep listening to guided hypnobirthing podcasts, all of which eventually helped me to overcome my anxieties about giving birth. I had to learn how to be the patient, not the provider, and to have faith in my husband, family, and healthcare team to take care of me. By all accounts, I had a very normal pregnancy and easy birth. At the pediatrician visits with my daughter, I filled out mood questionnaires at every visit to screen for postpartum depression, which thankfully I didn't develop, but it did make me wonder, why aren't these types of questionnaires available throughout the entire pregnancy?
Okay, I've gone through a lot of physiologic changes so far.
I'm trying to think of other...
Don't ask me more questions. I'm going to keep going.
I'm trying to think of other body parts, or what other body systems.
Yeah, they're not the ones you would think of necessarily. Brain is interesting. Your brain definitely changes during pregnancy, and there are like fetal cells that make it all the way into your brain.
Yeah.
But I don't have data on like what are the changes. We have no idea. What I'm going to do is now focus more on the two other major complications that we see and the body systems that they're involved in. So, diabetes. Okay, this is our endocrine system. And we already know that our endocrine system, which is our hormone system, you defined it, So our entire hormonal milieu is changed during pregnancy.
Yeah.
And people end up susceptible to diabetes during pregnancy in large part because of a hormone that the placenta is secreting that's called human placental lactogen. There's other stuff that it's involved as well, but this is what I'm going to focus on.
Okay.
Because what this does is it makes our pregnant bodies less sensitive to insulin. We have an increased insulin resistance.
Okay.
Why do we need an increased insulin resistance? If we remember back to our diabetes episode, insulin's job, what it does in our body, is when we have high glucose in our, like we eat something, right? And we have high glucose in our bloodstream, insulin is secreted and it tells the glucose, like, get away from here. Pack yourself away so that we can store you and use you later. Okay? So insulin puts glucose into our cells, but a fetus needs glucose and they get it from our bloodstream.
Got it.
So by making our insulin less effective, you can have more glucose to be available for the developing fetus. But if this process goes too far, like if our pancreas, because we're going to have this insulin resistance, right? So our cells are going to recognize, hey, glucose is too high. We need to make more insulin.
Yeah.
If your pancreas can't keep up with that increased demand, then you end up with gestational diabetes, where we see too much glucose in our bloodstream.
Okay.
Levels get too high. And that has a couple of big consequences. One is it can cause increased growth of the fetus, right? Because the fetus is just like getting a glucose pipeline.
Yeah.
Okay. And that is called macrosomia. So it ends up being large babies or large for gestational age babies. And that can make delivery very risky.
Yes.
Okay. But the second complication that I don't think people talk about as much is that while our glucose that's in our bloodstream passes through the placenta and into the fetus, our insulin does not. So if our glucose levels get really, really high, fetus inside of us has to make more and more insulin because their body is also like, whoa, this is a lot of glucose.
Yeah.
So they're having an increased amount of fetal insulin that they're making. And then after they're born, that sugar syrup bloodstream pipeline is cut off. And now they can get severely hypoglycemic because of how much insulin they've made in their bodies.
And so then what does that look like?
That can end up with seizures or coma or death.
And that is like immediately following birth?
Right.
Or when?
Yeah,
okay.
Exactly. So in the neonate, in the newborn, they can have really severe hypoglycemia. And so that's why babies that are born when the mom has had gestational diabetes have to be monitored really closely, especially in the first like 24 to 48 hours.
Okay. Can I ask some questions? You
can try, yeah.
Okay. When typically do we see gestational diabetes appear?
Okay. We usually test for it around weeks 24 to 28.
Okay.
Doesn't mean it can't happen before that or after that, but that's usually, in most places, that's the timeline that we test for it.
Okay. My second question is then what do you do about it?
Yeah, great question.
Okay.
There's a few different things. A lot of times it can be managed with just dietary changes alone. And so figuring out like what are you eating that is causing really big glucose spikes, and can you just modify your diet to be able to not have that, and then you're good. Otherwise, it's usually insulin. So we manage it with insulin.
My third question, what are the differences between first pregnancies and subsequent pregnancies? I would imagine that first pregnancies, your body's like responding and doing all these things that it's doing for the
your
first
body's
time.
Never done it.
Right. And then the second time, it's like, are those pathways carved out? How different are the hormone levels?
Yeah.
How likely are same complications to occur between one pregnancy and subsequent pregnancies?
That's interesting. So we'll talk definitely more about that with preeclampsia, which is what I'm going to do next.
Yeah.
But I don't know when it comes to gestational diabetes. Certainly, if you've had gestational diabetes in one pregnancy, you are at higher risk for having it in another pregnancy.
Okay.
Gestational diabetes is also associated with an increased risk of type 2 diabetes later in life.
Okay.
So it's thought to be kind of like a marker.
Yeah.
There's a lot of things that happen in pregnancy that are thought to kind of be markers, and we don't know, are they like causal, or are they just like a kind of a snapshot in time where we're like, oh, maybe you are at higher risk for these complications later in life, but it's not like because you had it during pregnancy. Does that make sense?
Yes.
But yeah, I don't know data on like what are the rates first pregnancy, second, third. It also is going to vary with age as well too. So yeah, I don't know. That's an interesting question though when it comes to diabetes.
Yeah.
I don't know. Overall though, the estimates of like how many pregnancies are complicated by diabetes are like all over the map, from like 1 to 30%, depending on your study. So it's like, who knows?
What's the threshold? Like, how do you
diagnose it?
How do you diagnose?
I really wanted to bring in a glucola for you, but I couldn't get my hands on one, so I'm sorry. And it does differ. Different countries and different guidelines are a little bit different in terms of how exactly you diagnose it. But most of the time, it's by doing a glucose tolerance test. And so you give somebody a fixed volume of glucose, 50 grams, 75 grams, whatever, and then you test their blood at intervals, either 1 hour, 2 hours, 3 hours, or multiple times.
Okay.
And then see what their numbers are.
Got it.
What their glucose level is.
Okay.
And there's different cutoffs, and that part's boring, so let's move on, shall we?
Yeah, I want to, preeclampsia.
Preeclampsia.
Yes. Big one.
So it is the biggest. It is a doozy, and it can be, for sure, probably the most severe complication of pregnancy. That might not be true, but it's a big one.
It's a big one.
So this is really, truly not just, it doesn't fit as neatly in a single organ system because it is, like you mentioned, Erin, the result of a kind of dysfunctional relationship, really, between the placenta and our own cardiovascular system. Mm-hmm. And it can result in a whole spectrum of disorders that we call hypertensive disorders of pregnancy. So it's not just preeclampsia. It also includes gestational hypertension, so just high blood pressure.
Okay.
Preeclampsia and eclampsia, and then also HELP, which is hemolysis, elevated liver enzymes, and low platelets. But often we think about and focus on preeclampsia because that is a kind of point at which if this kicks in, if it's officially preeclampsia, then that's when the risks to both fetus and mom become pretty significant.
Okay.
Preeclampsia overall is estimated to complicate between 4 and 5% of all pregnancies worldwide.
That's such a high rate.
It's pretty high.
Yeah.
And it's estimated, and estimates on this really did vary in several papers that I read, but most reliably, the papers that I read said it's estimated to result in 70,000 maternal deaths every year and 500,000 stillbirths or neonatal deaths.
Oh my gosh.
Which is just like heartbreakingly massive numbers.
Yeah.
On top of that, for every maternal death that's related to preeclampsia, it's estimated that 50 to 100 women are having significant morbidity as a result of it. So it's like affecting a huge number of people.
Yeah.
And I'm sorry that started off like so heavy, but preeclampsia can get really scary.
Yeah, absolutely.
So in terms of like when I say preeclampsia, what does that mean?
Right.
It's defined as hypertension, so elevated blood pressures, and at least one of a few other features, symptoms that we see. One big one is protein in the urine, because that's a sign that your kidney is being affected.
Okay.
Or sometimes other signs, other lab values that we see that tell us that your kidney is having kidney dysfunction.
And that's like it's not filtering
exactly.
well? Okay.
Exactly. Or liver dysfunction.
All right.
And all of those we do like laboratory values to see what those numbers are. Or sometimes it's diagnosed by neurologic complications, which can be severe persistent headaches, visual changes, stroke, or abnormal reflexes. Or sometimes it's hematologic complications, especially platelet abnormalities.
Okay, so there are a multitude of ways to diagnose.
A multitude of criteria that you kind of like check the boxes. And if you're meeting these, then it's called preeclampsia rather than just hypertension.
Interesting.
Yeah.
So that it would have to be like these neurological changes in addition to high blood pressure.
Exactly.
And you would also have to have protein in the urine or other liver enzyme elevation. Okay.
And what it can cause is a number of different things. From the fetal perspective, it can cause fetal growth restriction because of abnormal blood flow into the placenta. But when preeclampsia, especially if it goes untreated or unchecked, it can result in a number of really severe complications, including eclampsia, which is preeclampsia but with seizures. So that's the like line at which it becomes eclampsia rather than preeclampsia.
Downton Abbey.
Downton Abbey. Yeah. I know. I think of that too. And then it also can sometimes cause stroke, especially a hemorrhagic stroke, which would be a very severe complication of preeclampsia.
Okay.
Sometimes it's not the nervous system, but it's a different organ that gets mainly affected. So it can cause severe liver damage, and that often results in that HELP syndrome.
Okay.
Because it's causing damage to the liver.
Yeah. So HELP is
it's on the spectrum.
It's on the spectrum. So what is that spectrum? I know there's hypertension.
Gestational hypertension, preeclampsia, eclampsia, HELP.
Okay.
Yeah. That's like the main spectrum.
Okay.
But then within preeclampsia, we can also see these other and they're not discrete events necessarily. Like it's not like HELP or this.
Sure. Right. Okay.
Yeah. And preeclampsia also, it doesn't discriminate. It can cause severe complications to your kidneys and end up causing renal failure. It can cause flash pulmonary edema, meaning fluid onto the lungs, largely from just such high blood pressures, because that's something we see with severely elevated blood pressures outside of pregnancy as well. And then, like I said, for the fetus, it can cause placental abruption as well, which is where the placenta detaches spontaneously before the baby has been delivered, and that can be potentially catastrophic. And then also premature delivery or stillbirth. And we don't fully understand the mechanisms of preeclampsia. But you talked a lot, Erin, about what we know about the placenta and this relationship between abnormal or whether it's inadequate, like not deep enough, or too deep placentation. And what we think is that process results in these anti-angiogenic factors that float around in our maternal bloodstream and end up causing damage to our blood vessels. And that causes us to have this increase in blood pressure. And that is what ultimately leads to preeclampsia. So it's like inflammation and these like anti-angiogenic, so like not making enough blood vessels, not getting enough remodeling in the uterus. Right. And this whole like kind of perfect storm almost.
Signaling like, hey, there's not enough going on here. Send more.
Exactly. Yeah. And there is of course a lot of interest in understanding, like, are there biomarkers? Are there things that we can identify like in your blood to say either you definitely have preeclampsia or you are at higher risk of developing preeclampsia?
Yeah.
And in several countries, they actually do use a few different blood tests that test for a few different specific things. And I think I forgot to write down their names, but they're like PIF blah, blah, blah.
Some biomarkers.
Exactly, biomarkers. So far, as of 2024, we don't use those yet in the United States. So what we mostly look at in terms of trying to identify who is at risk for developing preeclampsia is what we know from the epidemiological data. And we know a lot about what the risk factors are that make someone higher risk for developing preeclampsia. We know that one of the biggest ones is having a previous pregnancy with preeclampsia.
Right.
The other huge one is having a first pregnancy. So you asked about the difference between like first pregnancies and subsequent pregnancies.
Yeah.
First pregnancies are generally higher risk for preeclampsia compared to second, third, fourth pregnancies, unless you had preeclampsia in your first one.
Right.
And then you're at higher risk during the other ones as well, too. And we don't fully understand that, but we think that it's related, again, to this immune tolerance thing.
Yeah.
Where your body has never seen these cells from this fetus floating around, and you develop this immune response to it. Whereas if you've had a pregnancy before and your immune system tolerated it, you are at lower risk of having an abnormal reaction to that in the future pregnancies.
Yeah.
If they're with the same paternal DNA. That
I find fascinating. And I didn't get into this, but there is a lot about paternal DNA and like exposure to paternal DNA before pregnancy. Yeah.
So like IVF pregnancies, especially those with donor sperm, are also a little bit higher risk than non-IVF pregnancies or IVF without donor sperm. So it's really, that's part of what lends support to this idea that there's like an immune tolerance spectrum kind of a thing.
Well, and it also makes sense then why subsequent pregnancies where the first pregnancy there's preeclampsia would have preeclampsia because it's like almost sensitized.
Exactly.
Like, oh, I've seen this before.
Right. Yeah. And I know what to do.
Yeah.
Right. Exactly. There's a lot of other risk factors, though. Having chronic hypertension prior to pregnancy. Maternal age, so increasing age increases our risk. Why? We do not know. And then a lot of other like medical complications that might affect the functioning of your organs prior to pregnancy, like kidney disease, things like lupus, which can affect blood clotting factors and things like that. Having a family history of preeclampsia. And then this part's really important, especially in the United States, race is a risk factor for preeclampsia. Specifically, Black people who are pregnant are at significantly higher risk of preeclampsia compared to white people who are pregnant. But that is not a biologic difference.
Right.
And that this is specified in the ACOG guidelines. This is due to systemic racism.
Yeah.
Because we also see that low income, regardless of race, which causes increase in life stressors, is also associated with an increased risk of preeclampsia. And so these are the kinds of differences that are really important to understand, because by recognizing who is at risk, we can we hopefully prevent preeclampsia.
How would one prevent preeclampsia?
So glad that you asked, Erin. Right now, the only thing that we have to help prevent preeclampsia is low-dose aspirin, of all things.
Okay.
So taking aspirin, which we did a whole episode on, and you might remember, is an anti-inflammatory agent that also irreversibly inhibits platelets from aggregating. So it stops your platelets from forming clots. And we think that these like micro thrombotic events are involved in the pathogenesis of preeclampsia. And so by irreversibly inhibiting this platelet aggregation, we've shown through a lot of epidemiological studies, that's what we think the mechanism is.
Yeah.
But we know that starting low-dose aspirin early in pregnancy, usually first or early second trimester, and continuing it until term can significantly reduce someone's risk of developing preeclampsia. Not make it zero. And the risks are different for whether it's term preeclampsia, preterm preeclampsia, or postpartum preeclampsia.
So what are those?
I don't have like
they are what they sound like.
They are what they sound like. It's like, when in pregnancy does it develop?
Yeah.
Most of the time, this is something that does not develop, or at least we don't see it, can't recognize it clinically until after 20 weeks of pregnancy.
Okay.
But it can potentially develop anytime. We might just not you might just not see the signs. It might be, that's part of why people are looking for biomarkers. Can we find it? Can we find evidence of this super early on?
Yeah.
But usually it's after 20 weeks. The earlier that you start to see preeclampsia, usually the worse the outcomes are, which makes sense.
Yeah.
Because you're just going to have a bigger effect on the fetus, and you're going to have a longer time that you're having potentially complications to the mother as well.
And postpartum?
And postpartum, we really do not understand. But you can develop preeclampsia for the first time postpartum, even if you did not have high blood pressure during pregnancy.
We have no idea?
No. And it is thought that term, because some people also don't develop preeclampsia until right at the end, right? They're after term, you're after 37 weeks, and you now all of a sudden have high blood pressure and then potentially preeclampsia. And we think that maybe those two entities are slightly different and less related to inadequate placentation early on, but maybe some other mechanism, but we don't know what that mechanism is yet.
Is that the same? Is it related to any bits of the placenta remaining, or getting stuck to?
Sometimes, yes. It can be from the placenta not fully detaching or something like that, but not always. So it's not as clear cut as that.
Right. Okay.
Yeah.
There's still something that's sending the signal of there's not enough oxygen.
Exactly.
Okay.
Yeah, but we don't know exactly how it works. And how is it different or is it not different, and that kind of a thing. In terms of other ways that we have to reduce the risk of preeclampsia, there's some evidence that maybe calcium supplementation might help, but it's not as clear cut as aspirin. And then in terms of if someone has preeclampsia, how can we prevent it from getting severe, or how do we cure it? Magnesium sulfate is given to prevent seizures, so specifically to prevent eclampsia. We don't know the mechanism or why it works, but it does. But the only cure for preeclampsia is delivery of the fetus and the placenta. But that is not only something that you have to balance getting to a gestational age where the fetus can survive and hopefully thrive, and also ensuring the health of the pregnant person.
Right.
And of course, that's not always the case, because postpartum preeclampsia does still exist. So it's a little bit complicated, and we don't fully understand it.
Do you have a breakdown for the percentages of each of those?
No, and I really tried to find that, but I don't. I don't have a good breakdown of that.
Okay.
Yeah. So that's preeclampsia, and really the overall physiology of pregnancy.
What about breasts?
I wasn't going to talk about breasts until 2 episodes from now.
We can talk about it then.
They do start to change early on in pregnancy. Yeah. You actually start to make colostrum in the second trimester, which is the first stuff that you secrete right after that the newborn usually eats for the first couple of days before your actual milk comes in.
Food aversions, food cravings.
Dunno.
Okay.
There's a lot of talk about like the evolutionary significance of nausea and vomiting and food cravings, and is it so
how
that we
peaks at the time that the fetus is most vulnerable to toxins crossing the placental barrier?
Right. But I don't know.
I mean, there seems to be some basis to that, like Darwinian medicine or whatever.
Sure. But I don't know more about it than that. But what I think is so interesting, and part of the reason that I am so astounded by and fascinated by the physiology of pregnancy, is that despite all of these changes to literally every organ system in our body, and despite all of the possible complications, some of which might be minor and not result in severe harm, and some of which can be very severe, despite all of that, the majority of pregnancies progress all the way to term and delivery without major complication, which is just astounding.
It is mind-blowing.
That our bodies can change so dramatically.
I have a question about that.
Okay.
Permanent changes. Mm-hmm. What are there? And then you can tell whether someone has been pregnant before, like looking at
a lot of times.
Changes.
I mean,
not all the time.
Yeah, not all the time. Yeah.
But what are those things that give that like signal that?
We'll talk probably more about that in the 4th episode when we talk about postpartum stuff.
Okay.
So I don't have like an easy answer to that question.
Okay.
But yeah, I mean, things change like in terms of cervix changes and things like that you can like maybe see on physical exam. There is evidence that like fetal cells remain in our tissues for like potentially the rest of our lives, which is crazy to think about.
I mean, again, it kind of is that relationship with cancer where it's it's interesting.
It's really, really interesting. But yeah, that's pregnancy, Erin.
in a short 1.5,
40
hours,
million years that I've took to explain all of that.
We went from deep time. We've really crossed hundreds of millions of years.
We went to deep
episode.
time all the way until delivery, which is
deep time to delivery
next week.
Yeah.
Mm-hmm. So
if
you'd like to learn more,
I have some sources here.
Oh, I bet.
There are 2 books that I read. One is called The Evolution of the Human Placenta, which is what it sounds like, by Michael Power and Jay Shulkin.
Okay.
And then there's Life's Vital Link, The Astonishing Role of the Placenta by Young Lok. Mm-hmm. Then those are the books. I think they were pretty good overviews of what's going on. It is an overwhelming amount of information. If you want to learn more about retroviruses, there are a few papers that I have posted. One is by Chung from 2013 called Retroviruses Facilitate the Rapid Evolution of the Mammalian Placenta.
Love it.
There are some other ones, too, about retroviruses that are good. Then there's Kschitz et al. From 2019, Evolution of Placental Invasion and Cancer Metastasis are causally linked.
Ooh.
Yeah.
Interesting. Bold statement.
Then from 2013, by Crosley, Placental Invasion, Preeclampsia Risk, and Adaptive Molecular Evolution at the Origin of the Great Apes, Evidence from Genome-Wide Analyses.
Wow.
Because humans are not the only species to get preeclampsia. Which we thought for the longest time that we were. But no, I think there was a gorilla at the Houston Zoo last year, the year before, something that had preeclampsia.
Poor baby.
I know.
Is she okay?
I think so.
Okay, good. I have a number of sources for this, some of which focus more on just the basic physiology of pregnancy. One that I liked that was easy to read was called Physiology of Pregnancy from Anesthesia and Intensive Care Medicine from 2019. I had a few others that were more focused on the cardiovascular physiology of pregnancy too that were great. A review paper on gestational diabetes called Gestational Diabetes Mellitus.
There you go.
Really creative title. From Nature Reviews Disease Primers 2019. And another from Nature Reviews Disease Primers on preeclampsia called Preeclampsia. It's not really creative titling.
I mean, I feel like it's pretty easy to understand what the paper's about.
You know what you're getting. It's
There's
a review.
No puns. We don't need puns in this.
And then there was a bunch more. So listen, check out our website, thispodcastwillkillyou.com, under the episodes tab, where you can find the list of all of the sources that we used from this episode and every single one of our episodes.
Every single one. A huge thank you again to everyone who sent in their firsthand account and shared them with us. We really can't thank you enough.
No.
Thank you.
Thank you.
We'll try, though.
Thank you again to everybody here at Exactly Right Studios for having us.
Yay.
We're super excited about it. Thank you, Tom. Thank you, Liana. Thank you, Jessica. Thank you, Brent. Thank you, Craig. Everyone.
Thank you, everyone.
There's so many other people.
This has been so much fun.
Yeah, it has.
Yeah. Thank you to Bloodmobile for providing the music for this episode and all of our episodes.
And thank you to all of you for listening and watching. And we hope that you enjoyed this episode and that you're ready for 2 more.
2 more. I know we still have so much to cover. It's wow.
Yeah.
And thank you to our patrons. You mean a lot to us. We really appreciate you.
Yeah. Thank you.
Yeah. Well, until next time, wash your hands.
You filthy animals.